everyone, and welcome back to the Deep Dive. Today, we're going to be taking a look at something that's super important for anyone building software in the healthcare world.
HIPAA game compliance.
You got it. So, maybe you're working on a healthcare app or a telehealth platform.
Or maybe you're just curious about data privacy and how it all works behind the scenes.
Exactly. Whatever brought you here, get ready, because we're going to uncover some fascinating insights.
That's we are. And HIPAA compliance is a big deal. It's not just about checking boxes. It's about protecting people's most sensitive data.
Yeah, their health data.
Exactly.
So let's start with the basics. What does HIPAA even stand for, and why should we care?
Okay, so HIPAA stands for the Health Insurance Portability and Accountability Act. It's a law that's been around since 1996 to protect patient health information and keep it private and secure.
Okay, that makes sense. But how does this actually impact software engineers? I mean, it's not like we're doctors or nurses.
Well, if you're building software that handles any kind of patient data, you know, think names, medical records, even billing information,
Right.
then you're in HIPAA territory. The law sets specific rules that software developers need to follow to make sure the data is protected.
Got it. So it's not just about hospitals and clinics, it's about anyone who touches this sensitive data. You mentioned rules. What are the most important ones that software engineers need to know about?
There are 4 main rules that directly affect software development.
Okay.
The privacy rule, the security rule, the breach notification rule, and the enforcement rule.
Whoa! 4 rules.
Okay, let's break those down a bit. What's the privacy rule all about?
The privacy rule focuses on giving patients control over their own health information. It dictates how that information can be used and shared, and it makes sure patients have rights, like knowing who has access to their data.
Right.
So unauthorized sharing, big no-no under this rule.
Okay, so it's about transparency and putting the patient in control of their own data. I like that. What about the security rule? Is that where things get more technical?
Absolutely. The security rule gets into the nitty-gritty of protecting electronic protected health information, or EPHI for short.
EPHI. Think of it like a blueprint for building secure systems. Everything from physical safeguards like locked server rooms to technical safeguards like encryption and administrative safeguards like employee training.
Wow, so it's a multi-layered approach to security. Makes sense. But what about when things go wrong? Is that where the breach notification rule comes in?
Exactly. This rule outlines what needs to happen if there's a breach of unsecured protected health information.
Okay.
It sets guidelines for notifying affected individuals, the government, and even the media in some cases.
Wow.
It's all about transparency and taking quick action to mitigate the damage.
Transparency is definitely key. No one wants to be left in the dark when it comes to their health information. And lastly, we have the enforcement rule. What does that one cover?
This rule is all about consequences. It outlines the penalties for violating EPA rules.
Okay.
And let me tell you, they're nothing to sneeze at. We're talking serious fines, potentially millions of dollars for organizations that fail to comply.
Yikes. Millions of dollars. That's a serious incentive to get this right. And speaking of getting things right, let's dive into the practical side of things. What are some concrete steps that software engineers can take to make sure their systems are HIPAA compliant?
There's a 6-step framework I like to use as a starting point. Think of it as a roadmap for building HIPAA-compliant software.
Okay, I'm ready for the roadmap. What's step number 1?
Step 1 is all about locking down that data. We're talking encryption and secure storage.
Encryption, secure storage makes sense, but why are these so important?
Well, imagine you pour your heart and soul into building this amazing healthcare app, only to have it all come crashing down because of a data breach.
Oh, no.
You could be looking at millions of dollars in fines lawsuits and at irreparable damage to your reputation.
That paints a pretty vivid picture. Suddenly, those hefty fines feel very real.
Yeah. And according to IBM's latest research, the average data breach in healthcare now costs a staggering $10.93 million.
$10.93 million. Wow.
That's why encryption and secure storage are absolutely non-negotiable.
Okay, you've convinced me encryption is clearly crucial. But can you break it down for me? How does encryption actually work in practice?
Sure. So there are 2 key aspects to consider: encrypting data at rest and encrypting data in transit.
Okay, at rest and in transit. What's the difference?
Okay, think of it this way. Data at rest is like the files stored on your computer's hard drive. They're just sitting there, not actively being used.
Right.
Encrypting data at rest is like putting those files in a locked safe. Even if someone breaks into your computer, they can't access the data without the key.
That's a great analogy. So what about data in transit?
Data in transit is data that's moving between systems. Sending an email or accessing a website. Encrypting data in transit is like sending that information in a secret code.
Okay.
Even if someone intercepts the transmission, they can't understand the message without the decryption key.
Ah, so it's like a digital lock and key system for data, whether it's sitting still or moving around. What are some common encryption methods used in healthcare software?
For data at rest, the gold standard is something called AES 256. Think of it as the Fort Knox of encryption. It's what you want, safeguarding your user's health information.
AES 256. Got it. And for data in transit?
For data in transit, you'll want to use something called TLS, or Transport Layer Security.
TLS. Okay.
You've probably seen this in action when browsing websites. It's what puts that little padlock icon in your browser's address bar.
Oh, the trusty padlock. I always look for that when I'm doing online banking or shopping. Good to know it's protecting health information, too. So we've got our data locked down tight with encryption. What's the next step in building a HIPAA compliant system?
Step number 2 is all about controlling who has access to that data. We call this access control.
Okay, access control. That sounds pretty straightforward.
It might sound simple, but it's crucial. Think about it. You wouldn't want the receptionist at a hospital to have the same access to patient records as a doctor.
Right? That would be a recipe for disaster.
Exactly. Access control is all about putting systems in place to make sure that only authorized people can access sensitive data. And there are 2 key parts to this authentication and authorization.
Cool. Break this down for me. What's the difference between authentication and authorization?
Authentication is all about verifying someone's identity. It's like proving you are who you say you are. Think of it like showing your driver's license or entering a password.
Okay, that makes sense. So authentication is step 1. What about authorization?
Authorization kicks in once someone's identity has been verified. It's about determining what they're allowed to do within the system, what data they can access, what actions they can perform.
Oh, okay.
It's about controlling access based on someone's role and responsibilities.
Right, back to that hospital example. The receptionist needs access to scheduling information, but not necessarily a patient's entire medical history.
Exactly. And to manage this effectively, we often use something called role-based access control, or RBA for short. You define different roles within the system, doctor, nurse administrator, etc., and each role gets a specific set of permissions.
So it's about granting the minimum necessary access for someone to do their job, no more, no less. That's a smart approach.
It is. And to keep track of all this activity, who accessed what, when, and from where we use unique user IDs.
So it's like a digital fingerprint for every action taken within the system.
That's a great way to put it. These user IDs are crucial for auditing and tracking, helping us ensure accountability and security.
All right, step 2, access control is in the bag. What's next on our HIPAA compliance checklist?
Step 3 is all about creating a clear record of everything that happens within the system. We call this audit trails and logging.
Okay, audit trails and logging. What makes these so important for HIPAA compliance?
Imagine you're trying to solve a crime, but there's no evidence, no fingerprints, no security footage.
Right?
It would be almost impossible to figure out what happened, right?
Yeah, it would be like trying to solve a puzzle with half the pieces missing.
That's exactly what it's like trying to investigate a security incident without proper audit trails and logs. They provide a record of every action taken within the system, who did what when they did it, and what data they accessed.
So if there's any suspicious activity or, heaven forbid, a breach, you can go back and see exactly what went down.
Exactly. And HIPAA actually requires these logs to be kept for at least 6 years.
6 years! They're serious about these records. What specific information needs to be included in these logs?
We need to be thorough. We're talking user IDs, date, and timestamps. The specific actions performed, any data affected the source of access, like the device or application used,
Right.
and even the outcome of the action, whether it was successful or not.
Wow. It's like having a super detailed diary of everything that happens within the system. But what if someone tries to tamper with these logs, cover their tracks?
That's a great question. To prevent tampering, we need to ensure these logs are tamper-resistant. We can use methods like write-once media or secure append-only log servers. Think of it like a digital vault where you can only add information, not delete or change existing records.
That's incredibly smart. So it's like a permanent, unalterable record of everything that happens. Are there any tools that can help with this logging process? I can't imagine trying to manage all of this manually.
Absolutely.
Yeah.
Automated logging systems are essential. They can not only collect all of this information, but also generate real-time alerts if anything suspicious is detected.
Oh, that's handy. Like having a digital watchdog always on the lookout. What kind of alerts are we talking about?
You could set up alerts for things like Multiple failed login attempts from a single user, unusual access patterns, or attempts to access data that's outside of someone's authorized permissions.
So it's not just about recording what happens, it's about proactively identifying potential issues before they become major problems. That's a real game changer. Speaking of proactively protecting data, what's our next step?
Step 4 is all about security in motion. We're talking about secure data transmission.
Okay, secure data transmission. I'm guessing this is about keeping that data safe as it travels between different
You
systems.
got it. Think about all the ways health information is exchanged electronically, patients filling out online forms, doctors sending prescriptions to pharmacies' labs, sending test results to hospitals. We need to make sure all of that sensitive data is protected while it's in motion.
It's like building a secure tunnel for that data to travel through. So how do we actually create that tunnel? What are the tools of the trade?
One of the most common and effective methods is HTTP SSL. You probably encounter this every day when browsing the web. It's what puts that little padlock icon in your browser's address bar.
Right, the padlock. I'm starting to feel like I'm becoming quite the security expert.
Mhm.
So HTTPS isn't just for online banking and shopping anymore. It's for protecting health information too.
Exactly. HTTPS encrypts the communication between your browser and the website you're visiting, making it much harder for anyone to snoop on the data being transmitted.
So it's like sending that data in a secret code that only the intended recipient can decipher.
You've got it. And this is crucial for any website or web application that handles PHI.
Makes sense. HTTPS takes care of web traffic. What about when data needs to be exchanged between different systems, like a hospital's database and a pharmacy system? How do we secure those interactions?
That's where API security comes in.
API security. I've heard that term thrown around a lot, but honestly, I'm not quite sure what an API actually is. Can you explain it in a way that even I can understand?
Think of an API as a digital messenger that allows different systems to talk to each other. For example, when you use a travel app to book a flight, the app uses an API to communicate with the airline system, to check for available flights pricing, and to make the reservation.
Ah, so it's like a digital go-between that enables systems to share information.
Precisely. And in the healthcare world, APIs are used to exchange all sorts of sensitive data, so securing those APIs is paramount.
Okay, that makes sense. How do we secure APIs and make sure those digital messengers are trustworthy?
It all comes down to strong authentication and encryption. We need to ensure that only authorized systems can access the API, and that the data being exchanged is encrypted both in transit and at rest.
So it's like having a secure communication channel between those systems with multiple layers of protection. That's reassuring.
It is. And in today's world where remote work and telehealth are so common, we also need to think about how to secure data when people are accessing systems from outside the traditional office setting.
Ah, yes, remote access. That's become so prevalent these days.
Exactly. And this is where VPNs come in handy.
VPNs. I know those are used for privacy while browsing the internet, but how do they apply to IPA compliance?
A VPN, or virtual private network, creates a secure tunnel between the user's device and the organization's network.
Okay.
So even if someone is working from a coffee shop or a home network, their data is encrypted as it travels through the public internet.
So it's like creating a private encrypted pathway for that data no matter where the user is located.
Exactly. It's a crucial security measure for anyone accessing PHI remotely.
Okay, I'm getting the hang of this. Secure data transmission is all about protecting data while it's in motion, whether it's traveling across the internet or between different systems. What's next on our journey to IPA compliance?
Step 5 is all about being mindful of the data we collect and how long we keep it. We call this data minimization and retention policies.
Data minimization and retention. Can you unpack those for me?
Data minimization is all about collecting and storing only the information you absolutely need to accomplish your goals. It's about resisting the temptation to gather a ton of data just in case you might need it later.
So it's like a Marie Kondo approach to data. Only keep what sparks joy, or in this case, what's absolutely essential.
Exactly. The less data you collect, the less risk you have. And data retention policies go hand in hand with minimization. They outline how long you need to keep certain types of data and set procedures for securely deleting that data when it's no longer needed.
Makes sense. Less data, less risk. But how do we actually figure out what's minimum necessary in practice? It seems like there could be a lot of gray areas.
There are. And that's where having a clear understanding of HIPAA's definition of protected health information, or PHI, is so important.
Okay, we keep coming back to PHI. Can we go a bit deeper on that? What exactly counts as PHI under API?
PHI is any information that can be used to identify a person, and that relates to their past, present, or future physical or mental health or condition.
So it's not just medical records, it's anything that could potentially link someone to their health status.
Exactly. This includes obvious things like names, addresses, medical record numbers, and diagnoses, but it also extends to things like billing information, insurance details, and even email addresses and phone numbers if they're connected to health information.
Wow, the scope of PHI is pretty broad. I can definitely see why minimizing the amount of data we collect is so important.
It is. And once we've figured out what data we need to collect, we need to put procedures in place for securely deleting it when it's no longer needed.
So it's not just about hitting the delete key, there's more to it than that.
Much more. We need to ensure that data is deleted in a way that makes it unrecoverable. This might involve overwriting the data multiple times using specialized data erasure software, or even physically destroying the hard drives containing the data.
Whoa, okay, so this is serious business. No digging through the digital trash bin to recover those deleted files?
Exactly. And whenever possible, we want to automate this deletion process to make it even more secure and efficient. Set it and forget it.
Okay, step 5, data minimization and retention check. We're almost there. What's our final step in building a HIPAA compliance system?
The final step is all about being proactive. It's about regularly assessing potential risks and vulnerabilities in your system. We call this conducting risk assessments.
Risk assessments. It sounds a bit intimidating. What does that actually involve?
It's not as scary as it sounds. Think of it like a health checkup for your software. We need to regularly look for any potential weaknesses or vulnerabilities in our systems and then take steps to mitigate those risks.
So it's about being proactive, identifying potential problems before they can be exploited by bad actors.
Exactly. And one of the most effective ways to do this is through something called penetration testing.
Penetration testing, what is that?
It's essentially hiring ethical hackers to try to break into your system.
Wait, you're hiring hackers. That sounds risky.
It might sound counterintuitive, but hear me out. These are ethical hackers, also known as white hat hackers. They use the same techniques as malicious hackers, but with permission and with the goal of identifying vulnerabilities so you can fix them.
So it's like a controlled experiment to see how strong your defenses really are.
Exactly. Penetration testing helps identify weaknesses that you might not catch through traditional security audits.
So it's like giving your system a stress test to make sure it can withstand real-world attacks.
That's a great way to think about it. And once those vulnerabilities are identified, we can put mitigation strategies in place to address them. This could involve patching software, strengthening access controls, or implementing additional security measures like intrusion detection systems.
Okay, so risk assessments are all about regularly checking your system for vulnerabilities, testing your defenses, and taking steps to mitigate any risks you find. Sounds like a pretty crucial step.
It is. And it highlights the importance of taking a proactive approach to HIPAA compliance.
So we've covered a lot of ground here today. 6 key steps for building HIPAA-compliant software data encryption access control audit trails, secure data transmission, data minimization, and risk assessments. Is that all there is to it? Are we done?
We've built a strong foundation, but there's more to the story. Meeting these basic requirements is essential, but to truly excel in this space, we need to go beyond the checklist and embrace best practices that weave security into the very fabric of our software.
Okay, I'm intrigued. Let's talk best practices. What's first on the list?
Welcome back to our deep dive into HIPAA compliance for software engineers.
It's great to be back. So last time we covered the 6 key steps for building HIPAA-compliant software. You know, data encryption, access control, audit trails.
Secure transmission.
Right, data minimization and risk assessments.
We built a solid foundation.
We did, but you hinted that there's more to the story.
There is. Meeting those basic requirements is essential, but to truly excel in this space, we need to go beyond the checklist.
Okay.
And embrace best practices that weave security into the very fabric of our software.
Okay, I'm intrigued. Let's talk best practices. What's the first one on our list?
The first best practice is to embrace the concept of privacy by design.
Privacy by design. It sounds like we're designing our software with privacy in mind from the very beginning.
That's exactly it. Instead of treating privacy as an afterthought or a bolt-on solution, we need to bake it into the core of our design process.
So it's not just about adding security features later on. It's about considering privacy implications at every stage of development.
Precisely. We need to think about data minimization from the outset, collecting only the data we absolutely need and ensuring it's handled securely throughout its life cycle.
Makes sense. So how do we actually put privacy by design into practice? It seems like a pretty broad concept.
It is, but there are some concrete steps we can take. For example, we can use data flow diagrams to map out how data moves through our system, identify potential privacy risks, and implement safeguards at each stage.
So it's about visualizing the flow of data and identifying potential points of vulnerability.
Exactly. We can also incorporate privacy impact assessments into our development process.
Privacy impact assessments, what are those?
They're essentially structured reviews that help us identify and evaluate the potential privacy risks of our software. Imagine you're building a new feature for your healthcare app.
Okay.
A privacy impact assessment would help you think through all the ways that feature could potentially impact user privacy and guide you in designing and implementing it in a privacy-conscious way.
So it's like a risk assessment specifically focused on privacy. We're essentially trying to anticipate and address potential issues before they even arise.
That's right. And by conducting these assessments early on, we can identify and address potential issues before they become major problems.
Okay, privacy by design is a great foundation. What other best practices should we be embracing?
Another crucial best practice is to leverage the power of CI/CD pipelines.
CI/CD pipelines. Refresh my memory. What do those stand for again?
CI/CD stands for continuous integration and continuous deployment.
Right. And if I remember correctly, it's all about automating the process of building, testing, and deploying software.
Exactly. And in the context of HIPAA compliance, CI/CD pipelines can be incredibly valuable for automating security checks and ensuring that our code meets HIPAA standards before it's released into the wild.
So it's like having a built-in quality control system that constantly checks for security vulnerabilities.
That's a great way to think about it. We can integrate automated security testing tools into our CI/CD pipelines to catch potential issues early on and prevent them from making it into production.
Right.
For example, imagine you have a tool that automatically scans your code for common security flaws every time you make a change.
Right.
If a flaw is detected, the pipeline can automatically block the release and alert the developers to fix the issue.
That makes a lot of sense. It's much easier to fix problems early in the development process than to try to patch them up later.
Absolutely. And speaking of catching problems early, another best practice is to implement vulnerability scanning tools like SonarQube.
SonarQube, we touched on that briefly last time. Can you remind me what it does?
SonarQube is a static code analysis tool that helps us identify potential security flaws, bugs, and vulnerabilities in our code base. Think of it like a spell checker for your code,
Okay.
but instead of looking for typos, it's looking for security weaknesses.
So it's like a digital detective that scrutinizes our code for any signs of weakness.
Exactly. And by running SonarQube scans regularly, we can catch these issues early in the development process and fix them before they can be exploited. For example, SonarQube can detect things like SQL injection vulnerabilities,
Right.
which could allow attackers to access sensitive data stored in your database.
That's a great addition to our security toolkit. Are there any other best practices we should be considering?
Absolutely. One of the most important but often overlooked best practices is to provide comprehensive security training for the entire engineering team.
Right. We touched on that earlier. It's all about empowering developers to write secure code and make security-conscious decisions.
Exactly. Regular security training helps raise awareness about HIPAA regulations, common security threats, and best practices for secure coding. Imagine a scenario where a developer unknowingly introduces a security vulnerability into the code.
Okay.
With proper training, they would be more likely to spot and fix that vulnerability before it becomes a problem.
So it's not just about knowing the rules, it's about understanding the why behind them and fostering a culture of security within the development team.
That's a great way to put it. And security training shouldn't be a one-time thing. It needs to be an ongoing process to keep developers up to date on the latest threats and best practices.
Makes sense. The security landscape is constantly evolving, so our knowledge needs to evolve as well.
Precisely. And speaking of evolving, another best practice is to leverage the power of third-party compliance tools.
Third-party compliance tools. What are those?
These are tools and services that can help automate and streamline various aspects of HIPAA compliance. They can assist with risk assessments, vulnerability scanning, log management, and even incident response. For example, imagine you're a small startup building a healthcare app.
Right.
You might not have the resources to build all of these security tools in-house. That's where third-party tools can be incredibly valuable. They provide a cost-effective way to access enterprise-grade security solutions.
So they're like specialized helpers that can take some of the heavy lifting off our shoulders.
That's a good analogy. There are many great third-party tools out there that can simplify the compliance process and free up our engineering team to focus on what they do best, building great software.
Okay, so we've got privacy by design, CI/CD pipelines, vulnerability scanning, security training, and third-party compliance tools. Any other best practices we should have on our radar?
One final but incredibly important best practice is to develop a robust incident response plan.
Right. We discussed incident response earlier. It's all about having a plan in place to handle security breaches, even if we've done everything right.
Exactly. No system is 100% foolproof. And when a breach does occur, we need to be prepared to respond quickly and effectively to minimize the damage.
Okay, remind me of the key steps in a solid incident response plan.
The first step is detection. We need to have systems in place to monitor for suspicious activity and alert the appropriate personnel as soon as possible. Think of it like having a burglar alarm for your data.
Okay.
If someone tries to break in, the alarm goes off and you can take action immediately.
So it's like having a network of security cameras and motion sensors constantly watching for intruders.
That's a good analogy.
Yeah.
Then comes containment. Once a potential breach is detected, we need to act swiftly to isolate the affected systems and prevent the attacker from gaining further access or spreading the damage. It's like containing a fire. You want to stop it from spreading to other parts of the building.
Right, like shutting down a section of the network to prevent the infection from spreading.
Exactly. Once we've contained the breach, the next step is remediation.
Remediation. That's about fixing the vulnerability that allowed the breach to occur.
Right, precisely.
Yeah.
This might involve patching software, strengthening security configurations, or even rebuilding entire systems from scratch. It's like fixing the hole in your fence that allowed the intruder to get in.
So it's not just about cleaning up the mess, it's about addressing the root cause of the problem and preventing it from happening again.
Exactly. And finally, we have recovery. This is all about getting things back up and running after the breach. This could involve restoring data from backups, rebuilding systems, and getting everything back online as quickly and securely as possible.
So it's like the post-disaster cleanup and rebuilding process.
That's a good analogy.
Mm.
But it's not just about restoring systems. It's also about learning from the incident.
You mean like figuring out what went wrong, how the attackers got in, and how to prevent it from happening again?
Exactly. Post-incident analysis is crucial. It's about documenting the entire incident, analyzing the attacker's techniques, identifying any weaknesses in our defenses, and updating our security posture accordingly. It's like reviewing security footage after a robbery to see how the criminals got in and what you can do to improve your security measures.
So it's like turning a negative experience into a learning opportunity, making the system even stronger in the process.
Precisely. And one final thought on incident response. It's important to remember that HIPAA has specific requirements for breach notification.
Breach notification, you mean informing patients and authorities if their data has been compromised?
Exactly. Yeah. HIPAA outlines strict timelines and procedures for notifying affected individuals and the Department of Health and Human Services in the event of a breach.
Okay.
These notifications must include specific details about the breach, such as the types of data involved, the potential impact on individuals, and the steps being taken to mitigate the damage.
So it's not just about fixing the problem internally, it's about being transparent and accountable to those who have been impacted.
Precisely. And failure to comply with these notification requirements can result in additional fines and penalties.
Wow. So it's a multifaceted process with serious implications. Okay, I think we've covered a lot of ground here today. But before we wrap up this deep dive into HIPAA compliance, are there any other key takeaways or insights you'd like to leave our listeners with?
I think it is important to emphasize that HIPAA compliance is not a one-time project. It's an ongoing journey. It's not just about checking boxes and then forgetting about it.
So it's not just about checking boxes and then forgetting about it.
Exactly. The healthcare landscape is constantly evolving with new technologies and threats emerging all the time. We need to be vigilant and adapt our security practices accordingly.
So it's all about staying ahead of the curve and continuously improving our security posture. What's fascinating here is that this isn't just about following rules. It's about understanding the spirit of HIPAA, which is to protect people's health information.
You've hit the nail on the head. It's about building that commitment to security and privacy into everything we do as software engineers.
All right, folks, that's all the time we have for part 2 of our HIPAA deep dive. But don't worry, we'll be back soon with part 3, where we'll explore even more advanced concepts and best practices.
Until then, keep exploring and stay curious.
Welcome back to the deep dive. We're wrapping up our exploration of HIPAA compliance for software engineers.
It's been quite a journey. We've gone from the foundations of HIPAA to practical steps and even explored best practices to build truly secure systems.
We've learned so much: encryption, access control, audit trails, the whole 9 yards. But I'm curious, what's next? What are some of the challenges on the horizon for HIPAA-compliant software development?
That's a great question. One of the biggest challenges we're facing is balancing security with usability.
Right. No one wants to use software that feels like Fort Knox, super secure, but clunky and impossible to navigate.
Exactly. But we also can't compromise on security. So how do we strike that balance? How do we make sure our software is both secure and user-friendly?
It's like walking a tightrope. What are some solutions?
One promising approach is something called adaptive authentication. It goes beyond static passwords and even multi-factor authentication by actually analyzing user behavior and context to adjust security measures in real time.
So it's like a security system that learns and adapts to the user's habits and patterns.
Precisely. Let's say a user typically logs in from their office computer using a specific browser. The system might require less stringent authentication in that scenario because it recognizes the familiar pattern. But if that same user suddenly tries to log in from a new device in a different country, the system might step up the security measures, maybe requiring additional verification steps.
So it's about being smart about security rather than just applying the same level of authentication to everyone every time, regardless of the situation.
Exactly. This not only enhances security by making it harder for unauthorized access, but also improves user experience by reducing friction for trusted users. It's a win-win.
Adaptive authentication definitely sounds like a step in the right direction. What other hurdles are out there when it comes to HIPAA-compliant software development?
Another big one is integrating legacy systems.
Legacy systems. You mean those older systems that might not have been designed with modern security standards in mind?
That's right. Many healthcare organizations still rely on these older systems, and connecting them with newer HIPAA-compliant software can be a real challenge. It's like trying to get two different languages to talk to each other.
I can see how that would be a headache. How do you bridge that gap without compromising security?
One approach is to use something called secure API gateways.
APIs again. I'm starting to understand why they're so important in the world of healthcare technology.
They are crucial. Think of an API gateway as a middleman between those two different systems, the legacy system and the newer HIPAA-compliant software. The gateway provides a secure and controlled way to exchange data between them.
So it's like a translator that speaks both languages, making sure the information is passed along securely.
That's a great analogy. And the gateway can enforce security policies like authentication, authorization, and encryption, ensuring that the data is protected even when it's moving between those different environments.
So it's like having a security checkpoint at the border between those two worlds. That makes a lot of sense. But even with all these strategies and tools, isn't it hard to keep up with the constant changes in healthcare technology? New regulations, new technologies, new threats. It feels like a moving target.
You're absolutely right. And that's why one of the most important skills for software engineers in this space is adaptability.
So it's not just about learning the rules once, it's about staying informed and constantly learning as things evolve.
Exactly. It's crucial to stay up to date on the latest IPA guidelines, security best practices, and emerging technologies. That might involve reading industry publications, attending conferences, taking online courses, basically never stop learning.
It sounds like lifelong learning is key in this field.
It absolutely is. And it's also important to foster a collaborative environment where developers can share their knowledge, discuss challenges, and learn from each other's experiences.
Right. Teamwork makes the dream work, especially when it comes to security.
Absolutely. And along the same lines, another important aspect of staying agile is establishing strong partnerships with security and compliance experts.
So it's not just the responsibility of the engineering team, it's a team effort.
Precisely. Software engineers should work closely with security and compliance teams to ensure that security is integrated into every stage of the development process, from design to deployment and beyond.
So regular communication, shared goals, working together right from the start. It sounds like communication and collaboration are really key to success in this space.
They are. And by fostering these kinds of collaborative relationships, we can create a more holistic approach to IPA compliance, where security becomes everyone's responsibility.
Okay, I'm seeing a common thread here. Collaboration, continuous learning, and adaptation seem to be the keys to navigating the ever-changing landscape of APA compliance.
You got it. And as we wrap up our deep dive, I want to leave you with this thought. HIPAA compliance is not just about checking boxes or meeting a set of rules. It's about embracing a mindset, a commitment to protecting sensitive patient data and building trust with users.
I love that. It's about seeing HIPAA compliance not as a burden, but as an opportunity to build better, more secure, and more user-friendly healthcare software.
You've got it. And by embracing that mindset, we can not only meet the challenges of today, but also shape a future where healthcare technology is both innovative and trustworthy.
Well said. Folks, that brings us to the end of our three-part deep dive into HIPAA compliance for software engineers. We've covered a lot of ground, from the fundamentals of HIPAA to emerging trends and best practices. But remember, this is just the beginning of your HIPAA compliance journey.
There's always more to learn, more to explore, and more ways to innovate while protecting sensitive data.
Keep diving deep, stay curious, and build amazing healthcare software that makes a positive impact on the world. Until next time, happy coding!